Boom! Alright folks, we're going again. So, final video in our series on Surds. It took us a while to get here. That is, if you would have been following video by video. Even more so if you would have been looking at each video in its entirety. That is always the recommended course of action. But you know, sometimes people these days, everybody busy and nobody have time. But if you're trying to learn something properly, you have to make time for it, not so? Right, so we're continuing with the whole idea of rationalizing the denominator. So now we finally had rationalization part 2. We had to talk about the conjugate first. We couldn't reach here without discussing the conjugate. In the same way that we couldn't talk about rationalization 1 without talking about the whole fraction. So we introduce a concept and then we go into the utilization of the concept. And here we are. So we're going to consider some typical examples of the kinds of surds you could get where you will need to rationalize a denominator. Right? So we looked earlier on at the case where we had a simple surd in the denominator, but the numerator was also a simple surd or a mixed surd. Alright? So we're going to start off this video by looking at the case where the denominator is a simple or mixed surd, and we're going to complicate matters by making the numerator a compound surd, just to make life interesting. Because discussing the topic in class is one thing, looking at a video is one thing, but then when you have to deal with the problem, that's another thing. So in my discussions here, I try to make the scenarios as interesting as possible. So let us say we have, for example, 5 plus root 3 over root 2. What are we going to do with that? The same thing we did in the last video. Because the main thing we're focusing on is the denominator. So in this case, yes, we multiply by the whole fraction. So this is the same thing as 5 plus root 3 over root 2 multiply by root 2 over root 2. We multiply by the whole fraction. Root 2 by root 2 is 2. 5 plus 3, 5 plus root 3 by root 2. See? And then that will end up being what? Well, you leave it like that. Root 2 into 5 plus root 3. So you write the final answer as root 2 into 5 plus root 3. Right? All over 2. If you write 5 root 2 plus root 6, you ain't really gain anything there. But I'll put it just for the sake. Right? So if you expand this out, you will get 5 root 2 plus root 6 all over 2. Right? So again, the whole idea is to rationalize the denominator by multiplying by its surd factor, and you get an answer with a rational denominator. Suppose instead of 2 root 2, we had 7 root 2 in the denominator. Well, let me do it. Alright? So we're going to do the same thing, but we change the denominator from root 2 to 7 root 2. Right? I'm going to go through the detail as painstaking as it is, because the whole idea is to do this once and to use the technology so that anybody coming after will just be able to go and look at it. So I'm taking my time and I'm going through it. No rush, no hurry. So if you have 5 plus root 3 over 7 root 2, right? So we write the denominator properly now. 5 plus root 3 over 7 root 2, right? And we want, well, we started off with this, and we want to rationalize. Well, then that is equal to that multiplied by, in the simplest form, 7 root 2 over 7 root 2. Now I'm going to get a little more technical with all that, because you saw from the previous video that all you really need when you're doing this is the root 2. You don't have to multiply by 7 root 2 by 7 root 2, because you're seeing the 7's cancelling out anyway. What you're focusing on is the surd factor. So since the surd factor is root 2, then here what? We just multiply by root 2 over root 2. So in other words, we have enough tools and knowledge to cut down on unnecessary work. That is also something that you have to keep in mind when you're doing maths. There will be times when you have the opportunity to cut down on unnecessary calculation, to cut down on unnecessary writing. But you will only get there by spending the time that you need to spend to learn the thing so well that you have the tools at your disposal. Just as we discussed in the previous video where we spoke about the difference of two squares. You have the tools at your disposal to cut straight to the heart of the matter without going through unnecessary working. Right? So it's not really a shortcut. You still have to do the work at the beginning to get to the point where in executing you could shorten your working. Right, so back to what we're doing here now. So what we end up with here will be what? 7 root 2 by root 2. Root 2 by root 2 is 2. Well, let me make the point now. So what you'll end up with will be what? 5 plus root 3 multiplied by root 2 all over 7 by 2, which should be root 2 into 5 plus root 3 all over 14. See? Rational again. Alright? And again, just for the sake of instruction more than anything else, because you don't absolutely need to do this, if you multiply it out, you'll get 5 root 2 plus root 6 all over 14. So we rationalize. So now we're going to make life interesting, because now is where we're going to actually start making use of the topic that we covered in the previous video, which is that whole conjugate story. Let me use the conjugate now and see it in action. So let us start by saying, for the sake of argument, that we have a new surd under consideration. This time, the surd we're dealing with is, watch it carefully now. Let me say 2 over 5 plus root 3. Right? And you want to rationalize the denominator so that you have a new fraction with the same value, but the denominator, instead of being a surd, the denominator is a rational number. So this will be equal to what? 2 over 5 plus root 3 multiplied by a whole fraction, which is a fraction where the numerator and the denominator are the same. What whole fraction are we looking for? Remember, we already stated before that we could choose any whole fraction we want, but you have to choose a whole fraction that makes sense for the context that they operate in. So when we were dealing with mixed surds and simple surds in the denominator, the whole fractions that we used were whole fractions where the numerator and the denominator was the surd factor of the original surd. But here it's a little more complicated. It compounds, so to speak, right? So we had to use something else. We have to use something else. What's that something else? In this case, that something else is the thing that we discussed in the previous video. That is the conjugate. So we're going to utilize the conjugate property to determine a whole fraction that we could use that would give us the effect of rationalizing the denominator. The denominator is the only thing we rationalize in. Right? So, what's the conjugate of 5 plus root 3? We know that the conjugate of 5 plus root 3 is 5 minus root 3. So all we do is multiply by a whole fraction where the denominator is the conjugate of this guy here, and of course, being a whole fraction, the numerator would be the same. And when we do that, what do we have? Well, let me work it out. What we will get coming down the road would be, multiply the numerators. 2 into 5 minus root 3 on top, all over. No, we're not going to multiply out all of that. We discussed that in the last video. And we said that once you're multiplying a binomial surd by its conjugate, you could go straight to the difference of two squares. And that is exactly what we're going to do. So here now what you'll end up with would be 5 squared minus root 3 squared. Which would be, let me leave it on as, let me say 2 into, let me leave it like this for now. 2 into 5 minus root 3 all over 25 minus 25 minus 9, minus 3, sorry. 25 minus 3, right? And then we're coming up here now, and we're saying 2 into 5 minus root 3 all over 25 minus 3 is 22. 2 into 22 would give us 5 minus root 3 all over 11. So watch, we end up with a rational denominator. See? Now, there's something that I want to discuss very quickly. Right? Usually, in situations like this, we don't expand the numerator immediately. And you actually saw why here. Because there are times when, in the course of your rationalization process, you might actually get a denominator that is a multiple or a factor of the number that you have here, in which case some kind of cancellation could take place and leave you with an even simpler fraction than you would have come out of the rationalizer than you would have come out of the rationalization process with. Let me say that over. When you're using all these fancy words, you have to be careful, you have to take your time. You multiply the two numerators and you get 2 into 5 minus root 3. Now, a lot of people, their immediate instinct would be to expand. And from there, you get 10 minus 2 root 3. Right? Don't go there. Right? So in other words, I've given all that little trick. Something to keep in mind. Leave it like this, where you have 2 into 5 minus root 3. The reason being, in the course of your entire process, you might end up with a denominator in the bottom that might either be a factor or a multiple of the integer that you have here. In which case, you could cancel across the fraction. So in this case, 222 is 11. So you ended up with a simpler version of this, which is 5 minus root 3 over 11. Right? So in other words, you give yourself the chance of possibly ending up in a situation like this. Because if you have 10 minus 2 root 3 over 22, there's a pretty good chance for a lot of students that they will not see that they could take the 2 out, take it back out basically, and then divide it into the 22. Once they reach here, they will be quite happy to reach there and move on. But you may find yourself in a situation where the question by its very nature requires the simplest possible form of the answer. Sometimes that is how it is. Sometimes you might be in a situation where this is acceptable, no problem, you take it and you run. But you might find yourself in a situation where this is what is required. You might need this to progress to another part of the same question, etc., etc., etc. So in other words, as a general rule, as a general principle, when you're working, you try to keep things as simple as possible. And in this case, this, let me change the color of the ink. This here is simpler than this. Right? You might tell yourself this is simpler than this. Because this here is where we actually factorize it. We break this down into its simplest form. In other words, we factorize it. But this is exactly what we will get if we just multiply the top. So we multiply the top and you leave it as is. And you proceed. And you could possibly get a cancellation at the end. So I'll take out 2-3 minutes just to explain our lecture technique. So we're going again. Next example. Suppose you have, let me see. We had, let me make life interesting now, man. Let me make life interesting. Let me go straight to the heart of the matter. Let us say, for the sake of argument, that we have, I will spare all that. Just a little extra, eh? Yeah, sometimes teachers will be tempted to take shortcuts too, you know. When that's happen, don't feel it don't happen. They feel it's only students know more shortcuts. Teachers, we know more shortcuts than all, you know, because we know the work. But I tried my best here to avoid the shortcuts. So there we go. We take a deep breath and we continue. Suppose you have a situation where you have, let me give them something, some kind of random something. Let me say you have 5 root 7. 5 root 7 over let me say 4 minus root 2. Alright, 4 minus root 2, no problem. We could go with that. 5 root 7 over 4 minus root 2, and we have to rationalize that. Right? So in other words, in the previous example, we had a whole number in the numerator. This time we make the numerator a little more complicated. We make it a mixed surd. Right? So we go through the same procedure. That'll be what? 5 root 7 over 4 minus root 2. We know that we're multiplying by a whole fraction where the denominator is the conjugate 4 plus root 2 over 4 plus root 2. Right? We multiply and what we get? That would be 5 root 7 in brackets by the brackets will be 4 plus root 2 in brackets. Right? All over, we already know what that will be. Difference of two squares. So that will be 4 squared minus root 2 squared. Which should be what? Again, we leave this as is. 5 root 7 into 4 plus root 2. So we are applying everything we just discussed there, right? All over 16 minus 2, which will be 5 root 7 into 4 plus root 2 all over 14. So in its simplest version, you have 5 root 7 over 4 plus root 2 all over 14. So we established here that there are no cancellation taking place there. In other words, this is not 15. If this was 15, then 5 into 15 is 3. And we're done with that. Right? But this is 14, so this is root 7 and not 7. So don't even think about cancelling root 7 into 14. That is madness. Root 7 is root 7. Root 7 is the square root of 7. That is not 7. Alright? So no, you cannot cancel. You can't take a 7 from under a square root sign and cancel it into a 14 down here. You cannot do that. Alright? So 5 root 7 into 4 plus root 2 all over 14. If you want, and I will do it only for the sake of demonstration, we could multiply it out. But there's a pretty good chance that you would need to multiply that out. But let me do it just for so now. Right? So 5 root 7 by 4 is what? 20 root 7 plus root 7 by root 2 is root 14. That'll be what? 5 root 14. 5 root 14 all over 14. This, same thing, but of course as a simpler form, because you leave the numerator in the factorized form where you have the two factors multiplied by each other. That is the simpler form. You break it down, you multiply, you get this, you leave it so. You don't need to do that, but we do it just for the sake of doing it. Right. So the last example I want to do is one where you have a compound surd in both the numerator and the denominator. Alright? So let me construct some examples now. Alright? Let me clear the board. Let you see how the thing is done. Serious matters, you know? It's serious. Alright? So we're going again. So if we have, let us say in our numerator, we have 1 minus root 2, and in the denominator we have, let's see, root 6. All right, let me say I have so far we have, what is the same thing earlier? I have 1 minus root 2 hold on. Yeah, 1 minus root 2. So let me say I have 3 plus root 6 over 1 minus root 2. Papa, yo, look trouble. Look thing. Suppose you find yourself in a situation like that, in a question somewhere, and you have to rationalize the denominator. In other words, you're basically trying to write the surd in a simpler form. And you simplify this particular surd by rationalizing the denominator. Again, we make use of the conjugate property. So that is equal to 3 plus root 6 over 1 minus root 2 multiplied by, we multiply by a whole fraction where the denominator is the conjugate of this guy here, and of course the numerator will be the same, so that will be 1 plus root 2 all over 1 plus root 2, right? You're multiplying, and that will be what? 3 plus root 6 in brackets by 1 plus root 2 all over, again, difference of 2 squares, 1 squared, there's a whole integer, we don't need no brackets, 1 squared minus root 2 squared. Wait a minute. That is equal to what? Multiply now. 3 by 1 is 3. In fact, no. We're leaving it just so, man. We leave it on top and we could always multiply it out at the end. So you have 3 plus root 6 in brackets by 1 plus root 2 in brackets all over 1 minus 2. So you'll get 3 plus root 6 into 1 plus root 2 all over minus 1. Yes, sometimes the value in the numerator, in the denominator, sorry, after you rationalize is actually negative. So it is quite possible to get a negative number in the denominator. Nothing wrong with that. It happens. So don't be put off when that happens. It happens, right? And now, of course, you could expand this out. And what you'll get? You will get, let me steal some space in the corner here now. You'll get 3. 3 by 1 is 3 plus 3 root 2 plus root 6 plus root 12. Root 6 plus root 12. All over minus 1. Which, if you have to write it more elegantly, you'll write it as minus into all of that. 3 plus 3 root 2 plus root 6 plus root 12. Ah, shucks. Right. This is 3 plus root 6, right? Let me see how we can steal some space here, boy. Let me see if we can make a squeeze. This is the same thing as minus into, I think we'll fit in 3 plus 3 root 2 plus root 6 plus root 12 all over 1. So in other words, again, I showed you another technique in this maths. Anytime you have a fraction where in the course of your working you end up with a fraction where the denominator is a negative integer, what we normally do is take the same negative sign and put it on top in the numerator. So in other words, we don't write our fractions with a negative sign in the denominator. Right? In the same way that we don't leave surds in a denominator, we don't leave negative signs in a denominator. And why can we do that? Remember we said, I'm not sure if I did the video for that yet, but I know I would have done it in live classes with my students, where I would have told them that where a negative fraction is concerned, minus 2 over 3 is the same thing as 2 over minus 3. Is the same thing as, let me write it up. I would have said to them that minus 2 over 3 is the same thing as 2 over minus 3. And both of them are equal to minus 2 over 3. See? So the placement of the minus sign doesn't matter in determining the actual value of the negative fraction. So whether you have the minus sign in the numerator, in the denominator, or outside covering the whole fraction, this is the final value. So that is why when we have this, we could do this. And in this case, because the numerator is actually 1, because the denominator is 1, what we will actually end up with would simply be, and I'm coming down in the bottom here now, minus into 3 plus 3 root 2 plus root 6 plus root 12. Alright? So even in the course of explaining the surds, we had the opportunity to, every now and then, we stop and we discuss some other aspect of general mathematical technique, general maths techniques. Alright? So, for all intents and purposes, we would have covered the theory of surds, different levels of surds. Right? And we ended up in this video with the rationalization of surds. The next step, of course, is to practice. Whether you use your textbooks, or whether you use your past paper questions, or whether you source questions on the internet, your practice is what will drive home and solidify everything that we would have covered in this series of videos on surds. And who knows, we may have left out something along the way, or some things along the way, in which case, as you come upon these things in the course of working your questions, you check it out, you deal with it, and almost certainly what you will find is that even if I would have left out something or some things in the series of videos, it would not be something so far removed from what we discussed that you wouldn't be able to just pick it up very quickly and run with it. Alright? So I hope that you would have gotten here as a result of going through all the videos in the entireties. Whatever your situation is, go forth and practice. Get better at this topic, master it, and then go through the same process and the same procedure for other topics in the AdMaths.